Our first analysis on ANSYS Workbench will be 1D structural analysis using bar element. In this, what we will do is, we will be going to determine the nodal displacement, stresses and reaction forces in this given problem. The stresses will be different in this section, the stresses will be different in this section. Here there will be definitely a reaction force. It is subjected to a force of 500 Newton. All right, all other material properties, areas, lengths is given to us. We can very easily analyze this kind of problem with 1D approximation or one dimensional approximation. The reason is, now its length or its dimension in the longitudinal direction is very large compared to its dimensions in the lateral direction. Also, if you see here, we need to only determine the nodal displacement, which will be again in this direction. We need to determine the stresses in each element, and also we need to find the reaction force, which will be again in this direction. So basically we are not interested in looking at what is happening in the other lateral directions. If this is our x direction, we are only interested to find the quantities in this x direction, also the applied forces in this direction, and so on. We are not really bothered about what is happening in y direction and what is happening in z direction. So therefore this kind of problems can be very easily solved by using 1D approximation. And then, as we know, since this is a bar, we will be using 1D bar element in finite element methods. We will be using 1D bar element to solve this problem. So now let us go to the ANSYS Workbench page, and let us see how we can solve this problem very easily in ANSYS Workbench. So as we had seen last time, since this is a static structural analysis wherein we just need to find the displacement for a static load, therefore what one may do is, one may just drag the static structural and paste it here. Wherever we see the green box, we can just drop it here. So after dropping it, you will get to see something like this. Now first of all, let us just save this project. Let us first save this project. So I will save it. You can save it anywhere the way you like. I will, for time being, I'll just save it on my desktop, and I will give it a name as 1D bar. All right, I will give it a name as 1D bar. I will not save it in desktop. I will save it somewhere in D drive. I can save it in any folder. You may save it in any folder in D drive. I'll save it here under 1D. I will save it as 1D bar. Make sure that you save it in some safe location. All right, this is the first step. Just save your project right in the beginning. Now let us rename this static structural as 1D bar. How you can do is, you can just click on this drop down icon, and then you can click on rename and call it as 1D bar. So this analysis is the static structural analysis of 1D bar. Now if you remember, our initial phase is of pre-processing, wherein we need to define engineering data, that is engineering material, geometry. We need to create a geometry, or we need to import a geometry, and then we have to set up a model, right? All this comes under pre-processing. So let us see how to define the material first. Let us see how to define the material. For that, what you need to do is just right click on this engineering data and click on edit. Depending upon your PC, depending upon the RAM and processor, it will take some time to open all this. So initially there is a material called as structural steel, whose properties are we can see here very nicely. All these properties, Young's modulus is 2 to the 2 into 10 to the power 11 pascals, Poisson's ratio is 0.3, and so on. But for our problem, the material property is given as E as 2 multiplied by 10 to the power 5 Newton per mm square for this segment. If this is our, suppose say, segment 1, and suppose say if this is our segment 2, then in this section, in this segment, in segment 1, E is given as 2 multiplied by 10 to the power 5 megapascals. So it is 2 multiplied by 10 to the power 5 megapascals. While entering in ANSYS, we can just enter it as 2E5, which it will take it as 2 multiplied by 10 to the power 5. Similarly, this we can enter it as 0.7E5. So we require basically two different materials. So what we will do is, we will not go with the existing structural steel material. If you can read here, click here to add a new material. So what we will do, we will just click there, and we will give a name to it. We will say material 1, mat 1. Okay, for the first section, that is section 1, we'll click material 1. Now it is showing question mark because we have not given any properties to it as such. Although we have created a material 1, but we are yet to give properties to it. So we know that this analysis is linear static analysis. The material is isotropic, which you can see here very clearly, that we have on the linear elastic, we have isotropic material. Again, if you cannot see this toolbox, what you can do is you can just click on view and click this toolbox. So basically we want a material which will take care of our linear isotropic material, right? We need to create a material which will take care of all this. So what you can do, you can click on this isotropic elasticity and then drag it and then just leave it on this mat 1. All right, once you do that, or you can just double click also on that. Once you do that, you will get to see this all this different material properties of this material mat 1 or material 1. In this we have to give minimum of these two values which are marked in yellow, otherwise we won't be able to proceed. This material won't be a valid material. So for this material to be valid material, we have to give at least these two properties, that is Young's modulus and Poisson's ratio. Now the Young's modulus of this material 1 is given to us as 2 multiplied by 10 to the power 5. I will enter it as 2e5. So if we enter it as 2e5, I can just press 2 on a keyboard, then E and then 5. But remember, this 2e5 is what? 2e5 is megapascals, right? It is not pascals. This is 2e5 is megapascals. So accordingly, we have to change this unit to megapascals. So it is, again I will have to enter, it is 2e5 and then press enter. So it has taken this value as 2e5. It is 2 multiplied by 10 to the power 5 megapascals. And Poisson's ratio, actually for one dimensional analysis we do not require Poisson's ratio because there are no lateral effects as such, right? If you remember, what is Poisson's ratio? Poisson's ratio is the ratio of lateral to longitudinal strain. But here, since this is one dimensional analysis, we are really not bothered about what is happening in lateral direction, y or z direction. So irrespective of whatever value we enter here, it will be fine. It shouldn't give any problem. For time being, we'll just enter 0.3. So this is about our material 1. We have defined what the properties of material 1. Once you define this E and mu, our job is done, because for a isotropic material we just require two material constants, any of these two material constants, in order to establish the stress strain relation and so on. And you must have noticed that once we had entered Young's modulus, the software automatically calculated bulk modulus and shear modulus. That is because all the formulas have been already fed in the software, right? But this is only about the material 1. What about material 2? Same thing. We just need to click on this, type it as material 2, mat 2, and then click here outside. It is again showing question mark. That means we have to give proper properties to this material. Double click on this isotropic elasticity or just drag drop here. Okay, so once we do this, again now we need to define the Young's modulus. We need to enter the value of Young's modulus. The Young's modulus of second material is 0.7 E5, which will enter it now. 0.7 E5, it is megapascals, right? So please don't forget to change this to megapascals, and then 0.7 E5, press enter. So it has taken the Young's modulus value. Poisson's ratio, again, it doesn't matter what value we give here in 1D analysis. We'll give it as 0.3. Other values it has calculated itself. So at this stage, what we have done, we have defined material 1 and material 2. Once we define these two materials, this part is done. We can just close it. Just close this tab here. Just press on this cross, it will close it. Right? Now it is always a good practice to save your work as and when you finish with these steps one by one. All right, so for saving you can either press Ctrl S on your keyboard or just click on this save icon. Now once this is done, now the next task is to define the geometry. Now once you right click on this geometry, we get the option of either importing the material, importing the geometry, or you can create it. All right, now if you are using the older version of ANSYS Workbench, then you will not see this space claim option. You will get, but definitely you will get this option, new design modular geometry. So we'll click on this new design modular geometry. Just click on that and it should open a new window, that is of design modeler. Depending upon your, again, your laptop speed or your computer speed, it will take some time to open that new window. You may see here that it is saying starting design modeler, right? So it is taking some time. Yes, it has opened. The design modeler is open. And this is basically like any of your modeling softwares, like say SolidWorks or Pro or CATIA, right? This window is used just to model your geometry. That's it. So how to model this now? What we will do is we can sketch on any planes as we do the sketching in any 3D modeling software. So what we will do, we will sketch on XY plane. To sketch on XY plane, what you can do is you can just click on this XY plane, then right click and then say look at. Okay, we could have even done this by one more method. Just click on this XY plane and then click on this icon here, right? Click on this icon and then again it will be same thing, just same as right clicking on this and saying look at. Okay, so once we do this, now we want to sketch, right? Now we want to sketch or geometry. Before that, if you just press your scroll button, if you press the scroll button and after pressing, if you continue to press and then just move your mouse, it is basically rotating the uh, frame, right? It is just rotating this frame. So if you had a model, you could rotate it very easily by just pressing the scroll button and rotating it this way. Okay, so basically pressing the scroll button and then moving your mouse will rotate the object or rotate the frame. Okay, so once again, if you want to sketch on the XY plane, right click and then say look at, or then you can even click on this Z axis, right? If you can just click on this Z axis, it will again be the same thing. It will show us the XY plane. Now once this is done, we are good to sketch. One more thing, if you want to just move this, if you want to pan this, then what you need to do is press Control and then click the scroll button. Press the scroll button and move your mouse. Okay. Simply if you press the scroll button and then move your mouse, it will rotate. But if you press the Control on your keyboard, Control key on the keyboard, and then along with the Control key, again if you press the scroll button, and then it will pan the object or the frame. All right, you will be able to move it in XY direction or YZ direction and so on. So again, to look at the XY plane, just click on this Z axis or right click and then say look at. Okay, once this is done, now let us sketch it. Okay, I will just pan it, I'll just shift it this side. So again, I'll press Control and then I'll press the scroll button and I'll bring it somewhere here. Okay, so now to sketch, what I will do, I will click on this sketching tab. Once I click on the sketching tab, I will get the following options. Under draw option, I will get the different options to, under the draw tab, I will get the different options to draw the parameters like lines and then tangents, polyline, polygon and so on. Under modifying tab, if you just click on this modifying tab, you will get to see all these modifying tools like fillet, chamber, corner, trim and so on. If you just click on this, if you just click on this arrow, you will be able to explore the more options under the modify tool, right? And then similarly, when you are in draw tab, if you just click this arrow, you will be able to see all the remaining draw options like rectangle, oval, circle and so on. And then if you want to dimension something, you can go here. If you want to give some constraints, if you can go here, you can click on the constraints. You'll be able to give different constraints to your sketches. If you go under setting, you will be able to put on or put off the grid and so on. Okay, so at this stage I will not be using grid. It is basically, this design modeler, this window is very similar to your 3D modeling or 2D modeling softwares, or like AutoCAD or 3D modeling softwares like SolidWorks and so on. Okay, so initially what I will do is I will go to draw, I will take a line, and then you can see here that it is showing me once I take my cursor to this origin, it is showing me P. It will take it as a point here. But suppose say if it is not showing you this P like this or the C like this, once you take on the horizontal axis, if you cannot see this P or C, what you need to do is go to constraints, come down, just keep on pressing this, come down, and then finally you will see this option auto constraints under constraint. Click on that and then make sure that these two options, that is global and cursor, is on. Okay, if it is off, and then if you say click on draw, you will not be able to see those constraints here like P and C and so on. That is very much required. So for that, what you need to do, go to constraints, click on this arrow, let all these options are visible, go to auto constraint and put on this two options, that is global and cursor. So once we do this, we will draw a line. Now we will sketch a line. Now before that, if you see here, the units are in meters, right? The units are in meters and degrees. So basically, if you draw a line somewhere from here to here, it will be of length 30 meters. That is what it is showing here, right? This scale, it is showing the length from here to here now is 30 meters. If you start zooming in, by the way, to zoom in and zoom out, you need to press control and then scroll button, and you just need to scroll it. Control and scroll will zoom in and zoom out, or without even pressing control, if you just scroll your button, if you scroll it away from you, it will zoom in. If you scroll towards you, it will zoom out. If you scroll towards you, it will zoom out. If you scroll away from you, it will zoom in. All right, so you can see that now it is in terms of meters, but if you remember our dimensions here, they are in mm, right? It is in 600 mm. Mostly all the engineering dimensions are in mm, unless and until we are dealing with very large structures. So what we will do is we will change these units from meters to mm. Okay, so units, they are in at present in meters, so we will click on millimeters. So we have changed our units from meters to mm. Now once we do that, now you can see that from this point to this point here, it is approximately 35 mm distance, or from this point to this point, it is approximately 70 mm distance. All right, so again I'll just zoom out. I will just zoom out. I'll just zoom out, and then I will press control. I'll press this scroll button. I'll just pan it here this side. All right, you can adjust it the way you want, the way you are comfortable. You just adjust this origin, and then we will draw a line. So click on the line, you will see this P point, click there, and then just after clicking, now you can take this line anywhere, but I will align it in such a way that I get to see this H letter. Now this H stands for horizontal, which will tell us that anywhere here, once I see the H, if I click somewhere, that means it will give me a perfect horizontal line, and which is what we want, right? We want a perfect horizontal line. So I'll pen it here, I will zoom in again, and then I have got a perfect horizontal line. Once I get a perfect horizontal line, I will go to the dimensions, click on the general, and then with that I will click on this line. It will automatically take this entire line, bring it down, and then again click it. Now it will show us that this dimension from here to here, that is the H1 length, is 84.229 mm. But we want it of a length 600 mm, right? We want it of length 600 mm. So H1, just click on this, and then just click on this number, and then put it as 600 and press enter. All right. So that means what we have done is, we have given it a dimension of 600 mm. We have just created a line of length 600 mm. So once we do this, once we create a line of 600 mm, then again what you can do, you can just scroll it towards you, and then you will zoom out, right? If you scroll it towards you, you will just zoom out. If you want to pen it, press control and then press scroll button, and you can pen it the way you want. All these options are even there here, right? If you just click on this, you can just pen it. If you click on this, and then you will be able to zoom it. If you click on this, and then if you highlight it, if you select a window, it will zoom here, and then so on. Okay, all these options are basically available here also, but better to use the shortcuts rather than going here at each options. Use this keyboard shortcuts. You press control and scroll button, you'll be able to pen it and so on. Okay, so we have been able to draw our first line. Now what is happening is, after drawing the first line, that is after drawing the line for this segment, there is a change in the cross sectional area for the second section, or for the second segment. There is a change in the cross sectional area. So in order to take care of this, what we will do is we will create now one more sketch. We will create one new sketch. We will totally create one new sketch because at present we are on sketch 1 on the xy plane. On the xy plane we are on sketch 1. Under sketch 1 we have sketched one line of length 600 mm. We will create one more line now, and how to do that? We will take a new sketch, and to create a new sketch, here I can click on this. I will click on new sketch. Okay, so this is my sketch 2. Now under sketch 2 again same thing, go to draw, click on line, click on this point. It is showing it as a, it is showing us as P. Then make sure that you orient it in such a way you get to see this letter H, that tells us that our line is perfectly horizontal. And then just click here somewhere at a point, random point. Then again go to dimensions, click on general, click on this line, drag it, and it is showing us this H2 length as 372, but we want this length to be how much? 500, right? 500 mm. So click on 500 mm. Now we have got two lines, H1 as 600 mm, H2 as 500 mm. Once we do this, our sketching is done. Right? We have finished with our sketching. Now we'll go back to the modeling option. That is, earlier we had clicked on the sketching. Now click on modeling. So we'll get to see our options back. But these are only the sketches, right? Our finite element method doesn't understand any sketches. It doesn't understand any sketches. It understands only the bodies. It has to be either a line body, or it has to be a plane body, or it has to be a solid body. It understands only bodies. So because of that, what we'll have to do, we'll have to convert these sketches, just these plane sketches, into the line bodies. How to do that? Click on concepts, go to the lines from sketches. All right, go to the lines from sketches, then click this first sketch, click only this first sketch, and then say apply. Once you click on apply, but it is showing that nothing is there, right? Here this yellow sign you can see. So for that, what you will have to do, in order to create a line body, you will have to click on this generate, or right click on this and click generate. Now once you click on generate, now you will be able to see that we have we have created one line body, which is this, right? We have created this line body. Now similarly, what we need to do is we need to create now one more line body for the second sketch H2. In order to do that, again same thing, what you need to do is go to concept, lines from sketches, then select this second line body, and then just one thing you need to remember after pressing apply, before clicking on generate, now make sure that this add material, you change this option to add frozen. Now there is a very good reason for this, which I will discuss in a while, but please make sure that don't leave it as add material, change it to add frozen. Now once this is done, again we will click on generate, and our second line body is also generated. So we have now two line bodies. Now what about this add frozen? See, what will happen is, if we do not select this add frozen, then later on in analysis we will fix this part, we will apply a load here. But since we had not selected the add frozen, what will happen is this load will not get transferred from this line body to this line body, because there will be no connection here in between. So then there will be some matrices error, and then the software will give you error, all right, because since there is no connectivity, proper connectivity. So make sure that whenever we create a second line body, before pressing on generate, please change this operation object to add frozen. All right, so we have given this, we have generated these line bodies, but is this complete? Because we have just made the line bodies, right? We have not given any cross section to it. We have just, if you see here, if you just rotate this by clicking the scroll button, just press the scroll button and then move your mouse, it will rotate. If you rotate, we see that there is no, absolutely no cross section to it, because we have not assigned any cross section to this line body, although we have created a line body, but it requires a cross section, right? So what we'll do next is we'll give it a cross section, we'll give a proper cross section to this line body and to this line body, and that you can check even here. Now if I click on this line body, it is showing me this yellow remark, right? Cross section is not selected. See, nowhere in this ANSYS, whenever you are working on this ANSYS, make sure that this yellow columns, yellow marks are not there. Yellow marks means it is asking us some data. It means the data is incomplete. We have to give it some data. So here it is asking us basically the cross section of this line body. Similarly, if I click on the second line body, this line body, it is again asking us the cross section. So our next task will be to create the cross section. Now the cross section of first first segment is 900 square, but they have not really told us whether it is circular or rectangle or square or something that way. So it is up to us, but make sure that the cross section can be anything, circular or rectangular or square or whatever, but make sure that its area is 900 square. So how to do that now? How to create 900 square? In order to do that, what we need to do is uh, go to this concepts and then click on cross section, and here we will create a rectangular cross section, because for us it will be easy to make it 900 square. How to do it? Just click on this rectangle. It will give us a pre constructed rectangle. We just need to adjust this dimension, this b and this h. So since we want a rectangle of cross section 900 square, I can make this b as 30, I can make this h as 30, and then the cross section of this will be 900 square. Now once this is done, but this is only the cross section of the first line body, right? We want the line cross section for the second line body as well. In order to do that, again same thing, just go to the concepts, say cross section, say rectangle, and then it will give us one more rectangle. But now in this case the cross section of the second rectangle is only 600 square, right? It is just a 600 square. So what we are going to do is, we will again give the dimensions as follows. This b, we will call it as 20, and this h, we will call it as 30. Now this gives us again this cross sectional area as 600 square. All right, so we have nicely defined both the cross sections. Rectangle 1 is for the first cross section, that is of 600 square. Rectangle 2 is for, rectangle 1 is for 900 square, and rectangle 2 is for 600 square. Now we need to assign it to these line bodies. We will go back to these line bodies. To the line body 1, we will assign, just click on this not selected, you will get this drop down menu. You just click on that and then assign the rectangle 1 for the first line body. All right, so we have assigned now the rectangle 1 as a cross section for the first line body. Similarly, for now second line body, assign this rectangle 2 as the cross section. Click on rectangle 2. Now that's it, we have done all of our work in this design modeler. We have nicely modeled the uh, geometry here. Now your question may be, although we have assigned the cross section, we cannot see it. That is because we have not activated that option to see the cross section. What you can do, if you really want to see the cross section, if it has taken the proper cross section or no, just click on this view and then click on this cross section solids. You'll be able to see the cross section here, right? You can nicely see the cross sections. You can nicely see the cross sections. All right, now before going to the other steps, just make sure that just click on this line body, press Control, click on the second line body. At the same time, highlight both this line bodies should be highlighted. Right click on them and then say Form New Part. Now this is very important. Why? Because it will act like a one part now. Although there are two separate line bodies, this was a separate line body, this was a separate line bodies, but now they will act as a same part, and that will take care of a proper transfer of load from this end to this end. All right. So make sure that we make one part body. So with this, we are good to go. Now, before going to the next step, I will just press the save project so that everything gets saved nicely. All right, and now we will go to the second part, that is model. This is where we will be discretizing our model, we'll be meshing it, and then we'll be giving boundary conditions and so on. So just right click on this and then say edit. It will take some time to open, but it will open. Depending upon your computer speed or depending upon your RAM and processor, it will take some time to open. You can see here it is saying starting mechanical, so it is in the process of opening the model. Okay, it is opening now, and it will be named as mechanical. All right. So since we are doing the linear static analysis, remember that whenever we open model, it will be named as mechanical. But if we go to the design modeler, it was named as design modeler, right? It was named as design modeler. So wherever we will be doing the modeling, or wherever we will be creating the geometry, that is named as design modeler. But once we right clicked on model, it open the mechanical, ANSYS mechanical. All right. Here we can see this line. This is basically our geometry. You might not be able to see it properly. It is just in a line format. If you want to see it in terms of its cross section, what you can do is you can just go to view and then click on cross section solids. Once you click on cross section solids, you should be able to see its cross section properly. Right? You should be able to see its cross section properly. And same thing applies here for a mouse control. Just to zoom in, zoom out, you need to scroll the button away from you towards you. If you want to rotate it, just press the scroll button and move your mouse. If you want to just pan it, press the scroll button along with the control key and then move your mouse. You'll be able to pan it. And then if you want to look at the XY plane, what you can do is you can just click on this Z axis. It will align it towards with the XY plane. So this is the bar, right? It looks more or less same as our given problem, right? It looks more or less same to our given problem. And then let us see now what all are the options here available in this model. We have geometry, we can see the cross section, coordinate system, connections, mesh, and so many things. First of all, just expand this geometry. Okay, expand this geometry, expand this part, and then we have the two line bodies. As we had created two line bodies, we have them. We have the two line bodies. But only thing what you need to note down is, see, for a first line body, that is this line body, let us just for a while, I will just put off this cross sections. Now this is the first line body, this is the second line body, right? You can see the highlight there, it gets highlighted in green color. Now for the first line body, just go down here and look at the material. Now the material which is assigned to this line body is structural steel, which is a default material. But if you remember, we have created two materials, material 1 and material 2. So for this line body, we should apply the material 1. So what you need to do is you can just click on this structural steel. You will get this option. Click on that. You will see here the two materials which we had created, material 1 and material 2. Click on material 1. Now once you click on material 1, that means now we have assigned a material as material 1 to this first segment. Similarly, same thing we have to do to the second line body. Just go down on the material, change that structural steel to material 2. That means now we have properly assigned the material 1 and material 2 to this two line bodies. And then the cross sections were nicely assigned. We can even check it again. Cross sections were assigned properly. Now we have also assigned the materials properly. Now once this is done, we need to mesh it. Now we need to change this geometry into the meshes, that is the node and element, because our finite element method again doesn't understand this geometries. It understands only the elements and nodes. In order to do that, what you can do is, first we'll do just a coarse mesh. You can directly right click on the mesh and then say generate mesh. Once you click on generate mesh, again depending upon your computer speed, it will take some time to generate the mesh. It is generating now, and then it has generated. We can see that there are around 1 2 3 4 5 6 7 8 9 10 11. There are 11 elements on this length, and there are around again 3 3 6 9 and 10, around 10 elements on this length. Okay. If you put off these thick shells and beams, if you just uncheck these thick shells and beams, you will be able to see the nodes and elements properly. These dark colors, these black colors are nodes, whereas these lighter ones are elements. Okay, so these are the nodes and elements which we can see here. Now if you are okay with the mesh, you can go ahead with this. If you want to still uh, do the fine meshing, if you want to increase the number of nodes and elements, what one may do is just click on the mesh and then go to sizing, and then here under element sizes, what was earlier, it was the default option. Just click and here you can give whatever size elements you want. But for a one dimensional bar element, this is more than sufficient. All right, this elements are more than sufficient. Even with one or two elements also, you will get the same results as that of the fine mesh in case of a bar element, so we need not worry about it. But if you want to change the size, you can always enter here, say if I want, say, each element of, say, 5 mm, let us say each element I want of 5 mm, so I have put now the element size is 5. Then in that case, see, now the mesh has been filled. So for that I will have to right click and then say update or generate mesh. Now in this case, what it will do is, see, it has created many number of elements and nodes, and here it looks almost like a line, but if you zoom in, you'll come to know. Now the distance between this node and this node is 5 mm, all right, because we have said that the element size should be 5. It has used 1D bar element of, say, length 5 mm. This fine mesh is not required here, so we can, if you want, you can keep it, or I can slightly increase the mesh size. I will say 20 mm, and then I will right click and then say generate. It won't make any harm if you go with the 5 mm size also. It won't make any difference as such. Okay, once this is done, we can just have a look at it. Again, click on Z axis, it will align it to XY plane. Now it is time to give boundary conditions. Now what are boundary conditions in our case here? The boundary conditions are, at this end it is fixed, it is perfectly fixed, right? It is a fixed support. And then on this end we have to apply a load of 500 Newton. So here this side, on the left hand side, we have to fix it. On the right hand side, we have to apply a force of 500 Newton. Let us apply that. In order to apply the boundary condition, click on static structural, and you will observe that here the options are changed. When we were on the mesh option, it was showing here all the mesh controls, different types of mesh controls. But the moment we click on now static structural, it will show us the options which are related to the boundary conditions. Okay, so first we will apply the support here, or the fixed boundary condition. In order to do that, we will go to, we'll go to supports and then fix support. There are now different types of supports which are listed here. I mean, different types of boundary conditions, but we will be taking the fixed support since this end is fixed, right? Now we need to pick this point, we need to pick this end, but our selection is on surface here, right? Now our selection can be face, it can be edge, it can be vertex, but now since here we want point, we will have to switch from surface selection to vertex selection. If we had to select the edge, we should have selected this option. In order to select face, we should have selected this option, but since now we want to pick a point, I need to select this vertex option, select this point, and then say apply, okay. Now once you say apply, you can see that this end has been fixed, this point has been fixed. Now this is all about the essential boundary condition, but now again we need to apply the load also, right? We need to apply this natural boundary condition also, and that is what, that is 500 Newton in this direction, in the direction of x, in the axial direction. So what we will do is, again we'll click on the static structural, we'll have here different kinds of boundary conditions. Go to loads, then click on force, and then again same thing, we need to first define the geometry. Here the geometry will be this end, now this end, and then say apply. Then we need to specify the magnitude of this force. In order to specify the magnitude of this force, just click on 500. So it has taken this force, magnitude of the force as 500 Newton, but now we have just given it a magnitude but not direction, and we know that the direction is along the axis, right? So in order to define the direction, what we can do is, I can just click on this, line. So it has taken now this force along this uh, axis, along this direction. So this is the 500 Newton force along this direction. And in case, suppose say if the arrow was coming this side, then we could have just clicked on this, so it will switch the direction. But what direction we had got initially is correct, right? Because the 500 Newton is applied in this direction. So we'll say apply.
Okay, this is one way of applying the force. The other way could be, I'll just delete it and show you. Okay, I have deleted this force. The other way could be again same thing. Basically, we will go to loads, we'll go to force, we'll say this as our vertex, we'll say apply. Now, in place of vectors, we can even define this force by component. Now, these are my x-axis, this is my y-axis, and this is my z-axis. I need to define a force of 500 Newton along x-axis, right, along x-axis. So what we will do is, will on the x component will enter it as 500, and then that's it. It will directly take the direction along x-axis. Suppose say if you wanted the arrow this side, if the direction was compressive, then we would have entered here the value as minus 500. Okay, now once this 500 Newton force is applied, now I think we are good to go. We have applied all the boundary conditions. So next step is just to solve it. And then if you remember, now if you remember, after this, after applying the boundary condition, our next steps were, it was the general steps were after pre-processing phase, wherein we have covered all this, we have finished all these steps. Now our next step is to solve it, right? And how do we solve it in the software? We just click on solve button, and that is what we are going to do now. We will just click on the solve button. Before that, it is always a good practice to save our work whenever we want to solve any of our problems. It is a good practice to save our project. That is because in case if there is any error and suddenly if your software closes, whatever we have done till now, at least that will be saved. So because of that, I have saved it. And then finally we need to solve. So either you can right click on the solution and click on solve, or that option is there here also, right? So it is one and the same thing. Just right click and then say solve. It will take some time. This is a very simple analysis, one dimensional analysis. It should solve very quickly. Again, depending on your computer, it will take some time. Depending upon your RAM, depending upon your processor, it will take some time, and it will solve this problem. Okay, it has solved this problem, all right, but we cannot see any useful information here although it has solved. That is because we are yet to complete our post processing step. Okay, so it has already, although it has solved, but we have to ask now computer whatever results we want from it. So what we will do, we'll right click on the solution set, we'll go to insert, and then we'll go to beam tools. Now what happens is, the moment we use the one dimensional elements, the one dimensional I mean the line bodies or one dimensional element, here everything, the all the solutions we get in terms of beam tools. So we'll go to beam tool and click on beam tool, and then if I just expand this beam tool, I'll get the following results. If I want the deformation, if I want the total deformation, what I can do is I can just again right click, I can say insert, and then I can go to again beam tool, deformation, and click on the total deformation or directional deformation. Anything is fine here, since this is just a one dimensional case. Now once this is done, once we have asked the software what all answers we want from it, we can just right click on the solution and then say evaluate all result. It will not be solving this problem again, now it will just evaluate it. So that is why this is called as post processing. Now once this is done, we can see all the green checks. That means everything has been found by the software. If I want to see check now the direct stress, I just need to click on this direct stress. And if I want to see the stresses on a proper cross section, what I can do is I can go to view, I can click on thick shells and beams. So now it is showing the stresses in the beams, and this is what we expect, right? And if you remember, in my first video I had said that we should have at least some idea like what should be our stresses. For that, what I had done is I had solved this problem, I mean I had solved this problem analytically by using our regular formulas of from mechanics of solids. That is, deformation is given as this, and the stresses comes to 0.83 megapascals and 0.5556 megapascals. Of course, this is possible since this is a very simple problem, But if you have a very complex problem, its analytical solution is not possible. Therefore, in fact, we will be using the softwares. But since this was an easy problem, I had just done all this calculations to see if whatever answers we are getting is right or no, and that will increase our confidence further to do more complicated problems, to solve more complex problems. So this answer is what was obtained by using direct formulas. I had also done the same analysis by using the finite element method, same procedure by finite element method, and then I had found all these values. So again I was getting the deformation as 7.6, and then the I had also obtained the reactions here. It was coming to, the reaction was coming to minus 500 Newton, and the stresses were again 0.83 megapascals and 0.5556 megapascals. And if you observe here, this is a throughout, this is a blue color, right? So what does this tell us is this blue is 0.556 megapascals, right? 0.556 megapascals. Here the units are in terms of megapascals, and then this red color indicates that it is 0.833 megapascals, which is almost same to what answers we have got. Yes, it is almost same to what answers we have got, right? This is 0.83, sigma 2 is 0.83, and this is 0.556. And the reason for the constant stress is because we know the stress formula is P by A. P is constant, even the area in this section, it is constant throughout, therefore the stresses are constant. And since this area is A2 is less than A1, the sigma 2 will be more than sigma 1, right? So everything is fine, we have got the proper values. Now if I want to look at the deformation, I can just click on this deformation, and then we can see that it is coming to 0.0076 mm, right? 0.0076 mm. And with the analytical calculations, we had also got this as 0.76, 7.6 multiplied by 10 to the power 3. This should be mm, all right? This should be mm. We had got same deformation even from the FEM calculation, 7.6 multiplied by 10 to the power 3 mm. So all the values what we have got is correct. Only thing is now we need to see the reaction force at the fixed end. For that what we'll do is we'll right click on this beam tool, we'll go to insert, we'll go to probe, and then we'll click on the force reaction. Now the moment we click on force reaction, it will ask us at which boundary condition we want to obtain the force reaction, because the reactions are obtained only at the boundaries, all right, only at the some supports. So we want that, we want it at the fixed support, we want this boundary condition at the fixed support. So click on this fixed support and it will obtain the reactions here. And in order to find the reactions, again same thing, just right click on this and then say evaluate results. Now it is showing us the reaction force is minus 500 Newton, which is true, right? Because since we had applied the force of 500 Newton, obviously the reaction this side should be minus 400 Newton. The minus sign indicates that it is in the direction opposite to that of x. So this way we have obtained all the required answers which was asked in the question. So this is all about the bar problem. In next video, we shall take one more problem. We'll try to solve a truss problem using ANSYS Workbench.